Today we're going to talk about sine, cosine, and tangent, also known as SOH CAH TOA. SOH CAH TOA stands for the trigonometric ratios, and we use that to find missing sides or angles of a right triangle. In today's lesson, we're going to focus on finding the sides of a right triangle by using sine, cosine, and tangent. Sine is a function of the angle that is the opposite side over the hypotenuse. Cosine of the angle is the ratio of the adjacent side over the hypotenuse. And tangent of the angle is the opposite side over the adjacent side. Our first set of examples just gets us used to the sides and how they're related. First thing we know is that in any right triangle, the side across from the right angle is always the hypotenuse. Okay, so the examples ask us first to find sine of angle T. All right, so SOH CAH TOA helps us remember what sides go with which trig function. Sine is opposite over hypotenuse. So here's angle T right here. Now the side opposite of angle T is 8. That will go on top. And the hypotenuse we've already identified as 17. So the ratio for sine of angle T is 8 over 17. Okay, let me get rid of that. The next one we're going to do is cosine of angle T. So again, here's angle T. Cosine is adjacent over hypotenuse. Adjacent means next to. So the side that is next to angle T is 15. And the hypotenuse is 17. Finally, they asked us to find tangent of angle G. Okay, here's angle G. Tangent is opposite over adjacent. Opposite over adjacent. So opposite angle G is 15. And the adjacent side would be 8. So it's 15 over 8. So now we're going to use those functions to figure out the lengths of missing sides. So what we're given here is we're given this angle right here is 55 degrees. Okay, we're given two sides in this problem. This side is x and this side is 12. We're going to use those two sides to figure out which of our three functions we're going to use. Sine, cosine, or tangent. SOH CAH TOA. Alright, so here's our vantage point right here in this angle. Now, what sides are we given? Now I know x is across from the right angle, so that's the hypotenuse. And this side here is next to that angle. So that would be the adjacent. So what function up here, sine, cosine, or tangent, uses the adjacent and the hypotenuse? That's going to be cosine. Adjacent over hypotenuse. So I'm going to set my problem up. Remember, it's cosine of the angle equals adjacent over hypotenuse. Now I'm going to plug in the information I know. Cosine of the angle, that would be 55. equals adjacent over hypotenuse. Adjacent is 12, and the hypotenuse is x. Okay, now to solve this equation, we're going to make it into a proportion. Now, anything that's not a fraction, I can put over 1. Now I'm going to cross multiply. Okay, so I have, the work looks like this. Okay, 12 times 1, that's 12. And cosine 55 times x. So how do I solve this for x? Now I'm going to divide both sides by cosine 55. Those cancel, and we have x equals whatever 12 divided by cosine of 55 is. So I want to punch my calculator. I'm going to punch it in as 12 divided by cosine 55, and then hit enter. Now, one thing you want to make sure is that your calculator is in the correct mode. Okay? So whatever type of calculator, you want to make sure that the mode is in degree and not radian. So if we calculate that correctly, and we're going to round to the nearest tenth, we get 20.9. That's the length of that missing side, which in this case is the hypotenuse. In the next example, our vantage point is where the angle 40 is. Now, what two sides are we dealing with? Okay, across from the right angle is the hypotenuse. And we're not using the hypotenuse in this case. Across from the 40 is x. That would be opposite. And next to the 40-degree angle is the adjacent side. So what function uses the opposite and adjacent? This is where our SOH CAH TOA acronym helps us out. Correct function to use would be tangent. Tangent is opposite over adjacent. So again, I'm going to set that up. Tangent of the angle equals opposite over adjacent. I'm going to plug in the information. So that's going to be tangent 40 equals opposite was x and adjacent was 16. Again, put that left side over 1 so you can cross multiply. X times 1 is x, and over here we're going to do tangent 40 times 16. So I'm going to go ahead and calculate that on my calculator. Tangent of 40 times 16. Rounded to the nearest tenth, you get 13.4. Now, if you get a crazy looking number that doesn't make a whole lot of sense, then your mode is probably not in the correct mode. It's probably in radian. You want to make sure your mode is in degree. So a quick summary here. When you set up your proportion, if your unknown value is on the bottom, you can see that our operation was division when we did our math. When we come down here to example B, our unknown, our x, was on the top of the fraction, and that told you to multiply when you did the math. Okay, so have a general idea of when do you multiply and when do you divide. Again, division is when x is on the bottom. Multiplying is when x is on the top. Okay, here's another example. Okay, here is the angle we're looking at right here is 46. And what two sides are we dealing with? Okay, let me write my acronyms up here so we can remember. SOH CAH TOA. Alright, now I know the side across from the right angle is my hypotenuse. And this side over here is across from that angle, which would be the opposite. So which function uses the opposite and the hypotenuse? That's going to be sine. So my work will look as follows. Sine of the angle equals opposite over hypotenuse. Plug in your information. Sine of the angle's 46. Opposite was 11, and the hypotenuse was x. Now remember, if x is on the bottom, I know we're going to end up dividing when I do my math. So I'm going to put this over 1 and cross multiply. Okay, 11 times 1 is 11. And then we have sine 46 times x. Here comes the division. Divide both sides by sine 46. And that should find our missing side. So x equals 11 divided by sine 46. Do that correctly and round to the nearest tenth, we get 15.3. That concludes this lesson on finding missing sides of a right triangle using sine, cosine, and tangent.